What is logic good for? Why do we want to study logic? So logic, among other things, is good for accomplishing two important and interconnected tasks. The first one is to make things explicit, to make our thoughts, our ideas, and our reasoning very clear and very explicit. And we will see various ways in which logic can help us do that. Second, logic allows us to identify good reasoning and distinguish it from bad reasoning. And these two features of logic are actually tightly connected with one another, because in order to understand good reasoning and distinguish it from bad reasoning, you need to make explicit what the reasoning is. You need to make explicit what the underlying thoughts are. So let's start with making things explicit. And here I want to talk about an example, cracking an egg. How difficult can it be to crack an egg? It's something that we do very often when we want to make an omelette or scrambled eggs in the morning. And we don't think about it too much, we just do it. But it's a very difficult action to carry out if you think about it. And in particular, think how difficult it would be to instruct a computer and telling the computer how to crack an egg. And it turns out actually that cracking an egg is a standard problem in artificial intelligence. So here is a quotation taken from the Common Sense webpage at Stanford University. Here is a very detailed description of how you might start thinking about making explicit the procedure through which we crack an egg, and how a machine or a computer could be instructed about how an egg can be cracked. So a cook is cracking a raw egg against a glass bowl. Properly performed, the impact of the egg against the edge of the bowl will crack the eggshell in half. Holding the egg over the bowl, the cook will then separate the two halves of the shell with his fingers, enlarging the crack, and the contents of the egg will fall gently into the bowl. The end result is that the entire contents of the egg will be in the bowl, with the yolk unbroken, and that the two halves of the shell are held in the cook's finger. So this is just a preliminary attempt to make explicit how an egg is cracked, what the procedure for cracking an egg is. So I hope this can tell you that cracking an egg, although we do it quite quickly and without thinking about it, isn't easy at all. Actually, cracking an egg requires a lot of knowledge, a lot of information. It requires knowledge about what eggs are, the geometry of the egg, and the material the egg is made of. This we could call the static knowledge about eggs. But it also requires dynamic knowledge about how to crack eggs. For example, the initial crack, what the initial crack looks like, and then the opening of the eggs. So by making this knowledge explicit, and this is what logic, as we will see in other parts of the course, allows us to do, we can instruct a computer. And in fact, many thought and still think that this is one of the key for artificial intelligence. Now, the other aspects of logic is that it gives us a way to identify good reasoning. and in general a way to identify good reasoning patterns and distinguish them from bad reasoning patterns. Here in these slides you see two of the most important patterns of good reasoning. One is called Modus Ponens and the other is called Modus Tollens. This is a terminology that comes from Latin. So let's look at Modus Ponens first. This one. So here is the general pattern of reasoning. If A, then B, A, therefore B, where A and B can be replaced by any sentence. And we will see a few examples later. Now it's called Modus Ponens from the Latin ponere, which means to basically place a conclusion. So the conclusion that is being arrived at is B in this case. And the premises are if A, then B, and A. And you can see that this is a good form of reasoning because if A is true, if A is true, and then if A, then B must follow. Then here we have Modus Tollens from the Latin tolerare, which means to remove. The conclusion here is not so much B, but the negation, not A, the negation of A. So in this sense, A is removed. That's why we call this Modus Tollens. This is less easy to understand as a reasoning pattern, but the pattern is if A, then B, not B, therefore not A. We'll see an example of that later on. So let's start with the case of Modus Ponens. If you take the medication, then you will get better. You are taking the medication, you will get better. This is a form of Modus Ponens. So A is you take the medication, B stands for you will get better. So if you take the medication, then you will get better. You're taking the medication, conclusion, you will get better. Let's see a second example of good reasoning. This is an example of Modus Tollens. If you take the medication, then you will get better. You're not getting better. Therefore, conclusion, you're not taking the medication. This is a form of Modus Tollens. So you see that the second premise is the negation of B. And the conclusion is the negation of A. So we can say at this point that good reasoning is reasoning that conforms to good reasoning patterns, to good forms of reasoning. And we have seen two good forms of reasoning, Modus Ponens and Modus Tollens. Let's look at another example from Monetarist Politics. So here is the example. Let's assume, given our knowledge of the US economy, that if the money supply were to increase at less than 5%, the rate of inflation would come down. Now, since the money supply is increasing at a rate well above 10%, we must conclude that inflation will not come down. Is this a good piece of reasoning? Now, in order to check whether this is a good piece of reasoning, first we need to make it explicit, and then we can check whether it conforms to a good reasoning pattern. So here is how we can make this explicit. Premise 1, if the money supply increases by less than 5%, inflation will decrease. Premise 2, the money supply does not increase by less than 5%. We're actually told that the money supply had been increased 10% in the example that we just read. Conclusion, inflation will not decrease. Now, this is the general pattern that this example embodies. If A, then B, not A, therefore not B. So A stands for the money supply increases by less than 5%, and B stands for inflation decreases, or inflation will decrease. And not A stands for the money supply does not increase by less than 5%, and not B stands for inflation will not decrease. Now, is this a good reasoning pattern or not? Now, if you remember Modus Ponens and Modus Tollens, this reasoning pattern that we see here does not mirror neither Modus Ponens nor Modus Tollens. So we can say that this is not a good reasoning pattern. But then what are the good reasoning patterns and what are the bad reasoning patterns? So we have seen two good reasoning patterns so far. And then if A then B, A therefore B. This is Modus Ponens, considered typically a good reasoning pattern. If A then B, not B, therefore not A, this is also considered a good reasoning pattern. In the example about inflation and money, this is the third reasoning pattern. If A then B, not A, therefore not B. Or if A then B, B, therefore A. These are typically considered bad reasoning patterns. But this begs the question because we want to know how can we distinguish between good reasoning patterns and bad reasoning patterns. So which patterns are good and which patterns of reasoning are bad? Here is another one, for example, if A then B, if B then C, if C then D, A therefore D. This seems to be a good reasoning pattern, but why is it good? And what about this other one? If A then B, if C then D, A and C, therefore B and D. Is this good and bad? Is this good or is it bad? Or if A then B, if C then D, not B and not D, therefore not A and not C. There is an infinite number of good reasoning patterns. We cannot list all of them. And so again, we are left with the question, how can we exactly identify good reasoning patterns from bad reasoning patterns? And this is something that logic will help us to do, as we will see later in the course.